Welcome everyone. In the previous class, we have seen the different phases of growth. Now, before going to this differentiation, first we will see the growth rate. Growth rate. Here, growth rate. It is with respect to time. Here, this is growth with respect to time. How much of growth has taken place per unit time? Growth rate is in respect to time, that is per unit time. It can be minutes, it can be seconds, it can be hours, it can be years. Time can be any, that is it can be in seconds, it can be in minutes, it can be in months, or it can be in years. But how much of growth has taken place in that unit of time? How much of growth has taken place in 1 minute, or in 1 hour, or in 1 year, or 10 years? So, per unit time, how much of growth has taken place? How much of growth has taken place per unit time? That is called as growth rate. So, growth rate is nothing but the amount of growth per unit time. How much of growth has taken place in a plant in a particular time. This time can be, I already said, it can be in minutes, or it can be in seconds, or it can be, months, or it can be years. So, we can take any parameter here, but with an amount of specific amount of time, how much of growth has taken place. So, that is called as the growth rate. That is called as growth rate. And this growth rate can be expressed mathematically. Growth rate can be expressed mathematically. Here we express growth rate in two, that is, one is arithmetic growth rate and second is geometric growth rate. Arithmetic and geometric. Here in arithmetic, we all know what is arithmetics. Here there is, in this arithmetic growth rate, there is continuous increase in size, there is continuous increase in number of, or constant increase or constant growth is seen. In this one, the growth is continuous, the growth is constant. Every time when it grows, it will be showing, or it will be showing the same. For example, here in this arithmetic growth, if this is one cell, arithmetic growth rate, if this is one cell, when this cell grows, here before dividing the cell will grow. After the growth of the cell will divide and it produces, when it divides, it produces 2 new cells. When it divides, it produces 2 new cells. Out of that 2 new cells, this one will be meristematic cell and the other will become permanent cell. The other will become permanent cell. One is meristematic and one is permanent cell. In arithmetic growth, this is one cell, the cell will grow, and when this cell divides, it will give rise to 2 new cells. Out of these 2 new cells, one will be meristematic and another will be permanent cell. One will be meristematic cell and another will be permanent cell. Now, these cells will again grow, and when they grow, they again give rise to, for example, this, it will again give rise to 2 new cells. Out of these new cells, here one will be permanent and one will be here meristematic. Again, when this, because it loses ability, when this become permanent now, it will lose the ability to divide. When this cell become permanent, this will lose the ability to divide. It will not divide. So that is why we are not showing any division here. Only meristematic cells will show division, permanent cells. So meristematic cells after maturation, they will change into permanent cells. They will change into permanent cells, and when these permanent cells, they cannot divide. So division will be shown only by meristematic cells. Division will be shown only by meristematic cells, and every time when this meristematic cell is dividing, it is producing two cells. Out of two cells, one is meristematic and another is permanent. It goes on like this. Again, if I say, if I divide, if this is divided, again here what will happen? This will be meristematic and this will be permanent. This is permanent and this is meristematic. So every time when the cell is dividing, it is giving rise to two cells. Out of these two cells, one is meristematic, which has the ability to continuously divide again, and another is permanent. The permanent one is not dividing, only the meristematic is dividing. So this type of division, this type of growth, it is constant. It is constant, that is every time when it is dividing into two. One is changing into meristematic, one is changing into permanent. One is changing into meristematic and one is changing into permanent. Here every time it is constant. There is constant increase in one cell. There is constant increase in one cell, and it is regular. It is regular. So here in arithmetic, continuous increase in growth is taking place. Every time when the cell is dividing, it is producing two new cells. One is meristematic and another is permanent. Every time when it divides, it produces two cells. Out of two cells, one is meristematic, which has the ability to divide, and the other is permanent. It loses the ability to divide. This permanent loses the ability to divide. So here the growth rate will be constant. Growth rate in the sense every time. For example, if this division is taking place every 10 minutes. So in every 10 minutes, two new cells are formed. Then again after 10 minutes, two new cells are formed. Then again after 10 minutes, two new cells are formed. At regular interval, constant increase in constant growth is seen. So this type of growth is called as arithmetic growth. Arithmetic growth. So here one progeny, because when we say when the cell divides, it produces two new cells. That new cells are called as daughter cells, or they can be even called as progeny. So when the cell divides and the progeny we get, one of the progeny will be meristematic, which has ability to divide, and one cell will be permanent, which loses the ability to divide. Two progenies, one will be meristematic and one will be permanent. So this type of growth is called as arithmetic growth. Now coming to second type of growth. This growth, that is geometric growth. Here what happens? Every time when it divides, now for example this is a cell. This is a cell. When it divides, it produces two new cells, two progeny cells. Here both of them, here both of the progeny cells are meristematic. In arithmetic, one was meristematic cell, that is one progeny was meristematic, one progeny was permanent. Here in this type of growth, in this geometric growth, when the cell divides, both the progenies will be meristematic. Both the progenies will be meristematic. Here it shows, here it is constant. Regular growth is seen, constant growth is seen at regular intervals. But here in geometric growth rate, the growth rate is exponential. It increases very rapidly. It increases very rapidly, and after a certain period of time it stops. So here 1 will give rise to 2 cells, 2 will again give rise to 4 cells, that is all of them will be meristematic. Okay, this 4 will again give rise to 8 cells, all of them are meristematic. That is 1 will give rise to 2, 2 will give rise to 4, 4 will give rise to 8, 8 will again give rise to 16. So like this all the cells are meristematic. So here it shows rapid growth, it shows rapid growth, continuous, because these are meristematic now, they will be continuously. In 1 minute, for example, in 1 minute it has produced 2 cells, here also it has produced 2 cells. In 2 minutes it produced only 2 cells, here it has produced 4 cells. So here there is exponential increase in the number of cells. Here it is constant increase, regular, at a regular rate the growth is seen. Here the growth is exponential, because with the increase in number of cells, then growth will be more. More the number of cells, more will be the growth. Less the number of cells, less will be the growth. Here the dividing cells are more. So these dividing cells are continuously dividing and produce even more number of cells. So here the growth in this pattern, in this geometric growth rate, here the growth is exponential, very rapid, very fast, exponential increase in cells. That is here both the progenies will be dividing. Both the progenies, here only one progeny is dividing, one is losing the ability to divide in arithmetic. But here in geometric both the progenies are dividing. That is both the progeny or both the daughter cells or the newly formed cells are meristematic cells. Meristematic cells. So here for example if we take this is a diploid zygote. I said you all the living organisms start from a single cell, that single cell is a diploid zygote. This zygote will divide and produce 2 cells. This is one cell, this is another cell. This will again, both of them are meristematic. This will again divide and produces 4 cells, that is 1, 2, 3, 4. All of them are meristematic. Here then again 4 will divide into 1, 2, 3, 4, 5, 6, 7, 8 cells will be formed. This will again divide and produces 16 cells. 16 will divide and produce 32 cells. Now when it attains 32 cells, what happens at this stage? Only few will be meristematic. In 32, for example, I am saying in 32 only 8 cells will remain meristematic. Other 16 will become permanent. Other 16 will become permanent, because continuously the cells cannot divide, because only a lump will be formed. These dividing cells need to grow and they need to be differentiated. So here after continuously dividing and producing a mass of cell, the process of differentiation will take place. That is, the cells will be given a particular task to complete. They will be assigned a particular or specialized function. The cells, the permanent cells will be assigned a specific task or specialized task to perform, and they will change into permanent cells. So that process is called as differentiation. So out of this 32 now 8 will be meristematic and other 16 will be differentiated and changes into permanent tissues. So this type of growth is called as geometric growth rate. In this, at the start, the increase in number of cell is exponential, very fast, very rapid, and both the progenies will be producing meristematic cells, that is dividing cells, whereas in erythematic every time it produces one meristematic cell and one permanent cell. In the next class we will see the different growth rates. We will plot this in the form of a graph and see